Although it may seem self-evident to us now, in the past it was not so obvious that, given two objects with different masses, they will fall at the same rate if dropped from the same height. Today, I present a centuries-old thought experiment that clarified this fact once and for all. We all know that F equals ma, or that a force is equal to an object's mass multiplied by its acceleration. On Earth, we approximate the acceleration due to the force of gravity to be g no matter where you are. So, given two masses on Earth, we can say with certainty that their acceleration due to gravity will be g. However, if their masses are different, their forces will be different as well. In fact, the mass of the greater magnitude will always experience a greater force due to gravity than that of the lighter. However, this presents a problem. This could imply that given a force due to gravity that is greater than another, the greater force must have a greater acceleration due to gravity, something that we know to be false. Instead, we know that a force due to gravity can be greater than another if and only if the mass of the prior is greater than that of the latter. We know this, but some of the greatest minds in human history didn't, so let's take a step back. Aristotle, Greek philosopher and physicist on the side, he hypothesized that a lighter object would fall slower than a heavier object, and therefore that the velocity of a falling object is proportional to its mass, further implying that heavier objects will experience a greater acceleration due to gravity than lighter objects. 16th century rolls around and the physicist, astronomist extraordinaire Galileo has a problem with Aristotle's hypothesis. He believes that he has the means to prove it wrong. He set out to devise a thought experiment that could easily debunk Aristotle's claim. What did he end up with? The now classic hammer and feather experiment, or Galileo's gravity experiment. He thought this: according to Aristotelian logic, if a light object and a heavy object, say a feather and a bowling ball, were tied together and dropped off a tower, then the heavier object would fall faster, and the rope between the two would become taut. This would allow the lighter object to create drag and slow the heavy one down. Hold on. But wait, thinks Galileo. I'm given my feather, and I'm given my bowling ball. But when the rope is taut, their masses add together. The weight of the two objects together should be heavier than the weight of either one by itself. In fact, because of that, this new system should be heavier than the weight of either one by itself, therefore making the system as a whole fall faster. So I've reached a contradiction. Galileo's all like, yo, Aristotle, I arrived at a contradiction. And Aristotle, he doesn't really see the point, so he's like, so what? But the contradiction that Galileo arrived at proved that Aristotle's hypothesis was incorrect, and that objects with different masses must fall at the same rate. There you have it, kids. Thanks to Galileo's famous thought experiment, you can safely say that the acceleration due to gravity is about the same everywhere on Earth. Thanks for watching.